Reference signals are transmitted as well-defined resource elements. A resource element is the smallest resource unit in LTE and translates to a subcarrier, respectively OFDM symbol. In the frequency domain, every sixth subcarrier carries a reference symbol out of the generated reference signal pattern. In the time domain, the spacing is 4 OFDM symbols as shown in the diagram. Thus, the resource block, which is 12 subcarriers, 7 OFDM symbols, when normal cyclic prefix is used, 6 OFDM symbols for extended cyclic prefix, contains 4 reference symbols at certain resource elements. LTE uses MIMO technology. 1, 2 or 4 antennas are used for transmission or reception. Depending on the MIMO mode, here special multiplexing, different data streams might be transmitted over the antennas. To ensure correct demodulation and decoding at the terminal site, the UE needs to distinguish between the different antennas. This is done with the help of the reference signals. As you can see in our example with the 2 antennas, the second antenna issues their reference signal pattern at other resource elements than the first antenna. The frequency and time domain spacing stays the same with 6 subcarriers and 4 OFDM symbols, but where the first antenna would issue their reference signal pattern, the second antenna would not transmit anything and vice versa. This is indicated by the hashed resource elements in the graph. With the help of the reference signals, the UE gets fully synchronized to the radio cell. After that, the UE looks for the physical broadcast channel, which carries the master information block. The physical broadcast channel is, as all control channel in downlink, QPSK modulated. Prior to modulation, the channel is scrambled with a cell-specific scrambling sequence. In contrast to the synchronization signals, the physical broadcast channel is transmitted on the 72 subcarriers around the unused DC subcarrier. In the master information block, the UE finds the information which system bandwidth is used in the cell. 1.4, 3, 5, 10, 15 or 20 MHz. The system frame number, as well as the configuration of a specific downlink channel. Further, the UE gets the information how many transmission antennas are used in that cell. And this is all what the UE knows after successful execution of cell search and cell selection procedure. Further information are required to execute random access procedure and to enter the network. Let's see how system information are distributed in LTE.
Andreas, I have a question. You explained that the repetition rate for the synchronization signals is 5 milliseconds, so every 5th subframe. What about the physical broadcast channel?
Yeah, sure, good question. The physical broadcast channel, and so the master information block, has a transmission time interval of 40 milliseconds and can be found in every radio frame. But of course you need to decode the 40 milliseconds to get the whole information. The data in the master information block are the only system information which are transmitted via a dedicated control channel, means the physical broadcast channel. All other system information are transmitted using the shared channel principle. That is what Christina explained during explanation of channel mapping in LTE. At that stage we learned that the logical broadcast channel can be either mapped to the broadcast channel or the downlink shared channel as transport channel. The BCH is then mapped to the physical broadcast channel, where the downlink shared channel is mapped to the physical downlink shared channel. So all other system information than the master information block are mapped to the downlink shared channel, which is a fundamental difference to 3G mobile communication systems. Nevertheless, also in LTE, system information that logically belong to each other are summarized in system information blocks. Further system information blocks with the same timing requirement can be grouped into so-called system information messages. First of all, the UE needs to find scheduling information for those system information, which is provided by the system information block type 1. This one is already transmitted using the shared channel transmission principle and has a repetition rate of 80 milliseconds. With information out of the system information block type 1, the UE would be able to check the periodicity for system information messages. There could be up to 32 messages. A message contains system information blocks with the same scheduling requirements. The system information block type 2 is the one the UE is now looking for, as this one contains information about the common and shared channel usage and therefore information how to perform random access. System information block type 2 includes information about the random access channel, which is the transport channel, and the physical random access channel, which is the physical channel where the reg is mounted to. Timing is the one side of the medal. The other side, which resource blocks, so which part of the spectrum now carries the system information message, and therefore the system information block. We will later on talk a little bit more in detail about this, but as Christina already highlighted during explanation of the downlink frame structure, the first symbols of each subframe contains the physical downlink control channel, PDCCH, and this one informs all the UEs about scheduling decision, and beside this, on which resource block system information can be found. A specific identity is used on the PDCCH to address system information to the UE. This is the System Information Radio Network Temporary Identifier, which is defined by 3GPP, the standardization body, and is therefore known by all UEs. With decoding the right resource blocks, the UE receives the information how to use the random access channel and how to access the physical random access channel and can perform the random access procedure.